Okay, so we're continuing down our little organic chemistry drawing. Isopropyl alcohol. This is rubbing alcohol. So nothing too wild about that. This is the structure of isopropyl alcohol. The way that we draw this is we have one, two, three carbons, and then coming off that carbon is an OH. The nice part about organic drawing is we don't talk about wedges and dashes. Usually, it doesn't mean it's never. All right. So that's isopropyl alcohol. Ethanol, this is it's fuel. It's E85 fuel. It's also worth about $80 billion. It's what's in booze. You get two carbons here with OH, one carbon, OH. Boom, done. Ethanol. This is caffeine. Who doesn't like this stuff? This is a stimulant, and we could ask ourselves, is this acidic or basic? If you remember back to chapter 9, you can see that these nitrogens all have those lone pairs. This is a basic molecule. Um, what I find strange about caffeine, and I'll ask this question a lot, is like, why is it a stimulant? Well, it increases your heart rate, this, that, and the other, but like, what does it do? How does it signal your body to do that? And so I think that's pretty fascinating. Why I think chemistry is really neat. But this is caffeine. You get this carbon right here. You get a carbon, 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 and then carbon up there. Oh, and one over here and here. This is what you'd call a fused ring because you have a six-membered ring here and a five-membered ring here, and they're fused together there with those two middle carbons. Morphine, by the way, I would never make you draw this from memory or anything like that. Uh, Morphine here, it's pain medication, super addictive. And this structure right here is something that crops up in a lot of addictive compounds, and you'll see what I'm talking about. So this is a six-membered carbon ring. We have another carbon ring, we have another carbon ring, and then this guy right here, see this there, there, and then to the nitrogen and back, it's a ring. Things are kind of on a plane, but it's a ring that pops out from everything else. And so morphine's a pretty complex structure, right? Ketamine, which is a way to start sedation, my understanding, looks like this. This one's got chlorine. Excuse me. For the first time, we're jumping into like the halogens, and so you can see a six-membered ring, six-membered ring. There's a carbon coming off this nitrogen. There's ketamine. Now, this is where I think things get kind of interesting. You can see codeine, which is also a painkiller, um, and it can be used as a cough treatment. This structure is the exact same as morphine. There's no difference there. The only part, there's one little tiny difference, and that's up here. Instead of an OH group right here, what you have is an O, then a CH3 group on the end. All right. So I think that's kind of crazy that we change one little thing and we completely change how this compound behaves. Sucrose, that's table sugar. So we're down here. Looks like this, a lot of OH groups. That's why sugar dissolves in water so well. You can see we have a carbon, 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 carbon. This guy right here, right there, this carbon has a bond this direction to a carbon, this direction to a carbon, to an O, and then there's an H that I haven't drawn because we don't draw H's. This is amoxicillin. It doesn't allow bacteria to form cell walls. Looks like this. Is this acidic or basic? It's actually a little acidic because we got this OH group on the end, but that's not why it does what it does. Um, so you can see amoxicillin's pretty big compound here. As we move on down, we have cocaine. It's really strong stimulant and it affects the reward pathway in the brain. You can see that it's kind of a complex structure, but does a lot of stuff to what's going on upstairs. Kevlar is a polymer. It just means that this unit right here, this NH and then this six-membered ring, then this NH and this guy, is just repeated over and over and over again. And what Kevlar does, which is what makes it interesting, is if you think about like a bullet is just like a glorified spear. It distributes force over an area. A spear is just a glorified stick with a sharp point, so the surface area is really small. And a bullet's just a spear that's made out of brass that moves really fast. And what this does is it takes it and it distributes the force over a larger area, but it will still crack ribs and things like that.